Oh, hey, welcome. Good day. Today, this video is called Trig Info, and so what we hope that you'll get before we're all done is some information about trig. And we're going to start with the basic information that you should know, and that is the what are called the parts of the right triangle. We've got our little girl here standing right inside of the triangle, and the way I talk about this is that one of the things is that when you're standing inside this giant triangle, right away you can stand, you can touch the adjacent side. Okay, that's this side right here, the adjacent side. The other side that you can touch is the hypotenuse. Okay, so you can touch the hypotenuse, you can touch the adjacent side, and the reason you can tell the difference between the hypotenuse and the adjacent is, well, because you look over here and you see the little right angle, and you go, oh, hypotenuse, right across from the right angle. So that one must be the hypotenuse. The one I'm standing on is the adjacent side, and the one that I can't touch because my arms are just not long enough is the opposite side. Okay? So we want to be aware of relative to the angles. If we're standing up in this corner, my hypotenuse would still be the same. This becomes my adjacent, and that becomes my opposite side, parts of a right triangle. We, of course, use those to define our trigonometric functions. Okay, so we've got my hypotenuse, we've got the adjacent side, and we've got the opposite side. And we're hopefully familiar with the sine of, well, I'm going to call it theta. The sine theta, which is just some angle that our little girl standing inside, is defined as the ratio of the opposite side to the hypotenuse. And the cosine of theta is the ratio of the adjacent side to the hypotenuse. And the tangent of theta is the ratio of the opposite to the adjacent side. Okay? So we have all of those ratios, and basically it just means that if, as the triangle, the same shaped triangle gets larger and larger, these sides grow proportional to each other, and the ratios that they form we give special names. The little mnemonic device that might help you to remember which goes with which, if you can remember how to spell it, SOHCAHTOA. And so SOHCAHTOA gives us those ratios. Okay, sine is the ratio of the opposite to hypotenuse. Cosine is the ratio of the adjacent to the hypotenuse. Tangent, opposite over adjacent. That's what the SOHCAHTOA part means. Now, you hopefully are also familiar with the reciprocal trig functions. Okay, so we know that the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. And the tangent of theta is the opposite over the adjacent. Okay, you might not be familiar with these other ones, which one of them is the cosecant of theta, which is the ratio of the hypotenuse to the opposite. And then we have the secant of theta, which is the ratio of the hypotenuse to the adjacent. And then we have the cotangent, which is the ratio of the adjacent to the opposite. Okay, and we abbreviate these CSC for cosecant, SEC for secant, and COT for cotangent. Okay, you'll notice that I strategically, or you may not notice, I strategically paired them. Okay, you might notice that the sine is just the reciprocal of the cosecant, or the cosecant is the reciprocal of the sine, the cosine is the reciprocal of the secant, and the tangent is the reciprocal of the cotangent. I think if you can figure out a way to try to get that clear, it's important that we have that going forward. So the other part that we have that goes with SOHCAHTOA now is this part. So I'm thinking and trying to spell it out for you. Okay, so we've got SOHCAHTOA, which is the regular ones, and then we have SOHCAHTEO, which is the back end one, and again it tells us that the cosecant is the hypotenuse over the opposite, the secant is the hypotenuse over the adjacent, and the cotangent, 2 letters, is the adjacent over the opposite, and I just need the 2 letters to make it a word. So SOHCAHTOA, SOHCAHTEO, those are the help you with the reciprocal trig functions. We'll be working with those quite a bit. All right, another thing that you should be aware of is that the tangent of theta is equivalent to the sine of theta divided by the cosine of theta. Okay, let's go back and we'll just use opposites and adjacents and see if we can't make that clear. So the tangent is the opposite over the adjacent, right? The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. Okay, so we've got two fractions, we're dividing them, so let's rewrite it so it looks like a division of fractions sort of problem. I know I said fractions that way, but anyway, there it is. Okay, and remembering hopefully that when we multiply with, or when we divide with fractions, we're actually doing multiplication in reverse. And so we invert and multiply. Okay, now with the help of the red pen, we can cancel out my hypotenuses, and we're just left with opposite over adjacent. So tangent is the same as sine over cosine. It's good information to have. Similarly, cotangent is the cosine over the sine. Some other identity information that we want to know about. So we want to know about the Pythagorean identities, and let's go with this one. The first one, the one that's probably the most important one to remember, and actually it turns out the only one that you really need to remember, is that the sine squared of an angle plus the cosine squared of the same angle is equal to 1. Okay, so there's number 1. We want to have that one. We can get the other two that we like merely by, first of all, just going through and dividing everything by sine squared. Okay, sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over the sine squared, what's the reciprocal of the sine? The cosecant. Okay, so there's number 2 that we should know about. Okay, if we now want to, let's see what I want to do. I'm trying to think. Oh, okay, to get the third one, we start with sine squared plus cosine squared equals 1. This time I'll go through and I'll divide by cosine squared. Cosine squared. Cosine squared. Theta to make it official. Okay, when I do this, sine over cosine is tangent. So sine squared over cosine squared is tangent squared. Theta, cosine squared over cosine squared is 1. 1 over the cosine, secant. Okay, so we've got 3 Pythagorean identities for the price of 1. So if you remember this one, the other 2 you can get just by some manipulation. This is the one that we tend to see more often. Occasionally we see this one down here. So have those sort of in mind and just be aware that they exist, Pythagorean identities. The other piece is degrees and radians. Okay, how do we convert? We tend to, in here, we use radians. Okay, so bear that in mind. The thing that you want to remember is that 360 degrees is equal to 2 pi radians. Okay. On the other end of the scale, 0 degrees is equal to 0 radians. So let's cut it in half. Let's get to 180 degrees. Well, 360 is 2 pi. Half of 360 should be pi. Let's cut it in half again, shall we? Okay, so if 180 is a whole pi, half of that should be half a pi. And we write half a pi as pi over 2. Okay, let's see. We cut that one in half again? Sure. Let's get 45 in here. I'm going to go off to the side a little bit. 45 degrees, it's going to be half again of this part. Half of half is a fourth. So we write that as pi over 4 radians. Let's see, 2 others that I want to squeeze in here. I'll squeeze it right here. 60 degrees. Well, if 180 is pi, 60 should be a third of a pi. Okay? And the other one that we tend to like is 30 degrees. Okay, and if 30 degrees is, let's see, which way do we want to go? Well, let's go this way. 180 degrees is pi. 30 is a sixth of that. So pi over 6 is the ratio. Okay, and we can use those same sort of things to get all these ones in between each one. Let's go to 270. 270, well, let's see, 0, half, 2 halves. This one's going to be 3 halves. Okay, so we write that as 3 pi over 2. So we'll work with that as we work on our trig card. That's one of the pieces that we want to develop, and we'll work through that. But that's kind of the starting point that'll get you most of the information that you need for the trig card. All right, other things that you need to know about trig: you need to be aware of the sine curve. The sine curve starts at 0, goes up to 1, back down to 0, back down to -1, and then back up again, and it follows that same pattern, as opposed to the cosine curve, which starts up at 1, goes down to 0, goes down to -1, and then back up. And it happens at these key pieces. So right here, this is pi over 2, pi, 3 pi over 2. So those 90 degrees or the quarter pi, half pi's are the pieces that we need to be aware of what goes on. So it just generally is a great idea to have an idea of the shape of the cosine curve and the sine curve so that you can work there. All right, I've bombarded you with information about trigonometry, and most of it, God, I hope all of it, you've seen before, but we just wanted to make sure. And if there's questions, you know where to ask. Hopefully you've learned something, and I, indeed, thank you for watching and listening. Talk to you soon.